So let's take another implicit derivative of this somewhat crazy relationship. And I've graphed the relationship here. As you can see, it is actually quite bizarre. E to the x times y squared is equal to x minus y. This is some of, at least in the range that's depicted here, the x's and the y's that satisfy this relationship. Well, let's take the derivative of both sides. So we'll apply our derivative operator to both sides. And actually, this is a good chance to maybe explore some different notation. We tend to be using that notation, but oftentimes you will see a derivative operator that just looks like a big capital D. So maybe we'll do that right over here. So let me make it clear. This is the equivalent of saying d over dx. I'll just use this big capital D operator so that you are familiar with the notation. And instead of using dy dx for the derivative of y with respect to x, I'm just going to write that as y prime. So we get a little bit of practice with different notation. So let's take the derivative of this thing right over here. Well, we're going to apply the chain rule. Actually, we're going to apply the chain rule multiple times here. The derivative of e to the something with respect to that something is going to be e to the something is going to be e to the something times the derivative of that something with respect to x. So times the derivative of x y squared. So that's our left-hand side. We aren't done taking the derivative yet. And on our right-hand side, the derivative of x is just 1. And the derivative with respect to x of y is just going to be minus, or it should just, I write negative dy dx. But instead of writing dy dx, I'm going to write y prime. As you can tell, I like this notation and this notation more because it makes it explicit that I'm taking the derivative with respect to x. Here we just have to assume that we're taking the derivative with respect to x. Here we have to assume that's the derivative of y with respect to x. But anyway, let's stick with this notation right over here. And every time, actually, let me make all of my y primes, all of my derivatives with respect to x, all my derivatives of y with respect to x. Let me make them pink so I can keep track of them. So once again, this is going to be equal to e to the x y squared times the derivative of this. Well, the derivative of this, we can just use the product and actually a little bit of the chain rule here. So the derivative of x is just 1 times the second function. So it's going to be times y squared. And then to that, we're going to add the product of the first function, which is this x, times the derivative of y squared with respect to x. Well, that's going to be the derivative of y squared with respect to y, which is just going to be 2y, times the derivative of y with respect to x, which we are now writing as y prime. Y prime, and then that's going to be equal to 1 minus y prime. That's going to be equal to 1 minus y prime. And like we've been doing, we now have to just solve for y prime. So let's distribute this exponential, this e to the xy squared. And we get e, or maybe I should say y squared times e to the xy squared. So that's that. Plus x, or let me say 2xy e to the xy squared y prime, the derivative of y with respect to x, is equal to 1 minus the derivative of y with respect to x. Now let's get all of our y primes on one side. So let's add y prime to both sides. So let's add, and just to be clear, I'm adding 1 y prime to both sides. So let's add a y prime to both sides. And let's subtract this business from both sides. So let's subtract y squared e to the xy squared to both sides. Subtracting from both sides. So we're going to subtract y squared e to the xy squared. And we are left with 2xy e to the xy squared plus 1 times y prime. We had this many y primes, and then we add another 1 y prime. So we have this many plus 1 y primes. That's going to be equal to That's going well. I purposely added y prime to both sides, and so we are left with 1 minus, this is kind of a crazy expression, y squared times e to the x y squared, and now we just have to divide both sides by this. And we're left with the derivative of y with respect to x is equal to this, which I will just copy and paste. Actually, let me just rewrite it. It's equal to 1 over, scroll down a little bit. It's equal to 1 minus y squared e to the x y squared over this business. 2, let me give some more space, 2xy e to the x y squared plus 1. And we're done. It was kind of crazy, but fundamentally no different than what we've been doing in the last few examples.